Today we will be looking at Nasir al-Din's proof of the sine law. We will be proving the sine law, which states that if ABC is any triangle, then C over sine C is equal to B over sine B and is equal to A over sine A. There are two cases which must be considered for this proof. One, where the triangle has an obtuse angle, and another, where all angles are acute. Let's begin with a triangle that has one obtuse angle. First, prolong CA to point D and BA to point T so that each is 60 units long. With centers B and C, draw the circular arcs TH and DE and extend BC. Now, draw perpendiculars TK and DF to base BC. Draw perpendicular AL. Triangle BTK is similar to triangle BAL. Thus, BT over TK is equal to BA over AL. Triangle CDF is similar to triangle CAL. Thus, DF over CD is equal to AL over CA. Now, multiply the right side of the equations and the left side of the equations to each other and cancel out like terms. First, multiply 60 over TK by DF over 60. Here, the 60s cancel out, giving us DF over TK. Now multiply BA over AL times AL over CA. The ALs cancel out, giving us BA over CA. Thus, we can now write DF over TK is equal to BA over CA. Since DF is equal to sine C, TK is equal to sine B, BA is equal to C, and CA is equal to B, we can change the formula to sine C over sine B is equal to C over B. Thus, C over sine C is equal to B over sine B. Now let's look at case 2, where all angles are acute. First, prolong CA to point D and BA to point T so that each is 60 units long. With centers B and C, draw the circular arcs TH and DE and extend BC. Now, draw perpendiculars TK and DF to base BC. Then, draw AL perpendicular to BC. Since triangle ABL is similar to triangle TBK, we know that AB over AL is equal to TB over TK. Additionally, since triangle ACL is similar to triangle DCF, we know that AL over AC is equal to DF over DC. Now, remember that DC is equal to 60, which is also equal to TB. Now, multiply the right side of the equations and the left side of the equations to each other and cancel out the like terms. First, multiply AL over AC by AB over AL. Here, AL cancels out, giving us AB over AC. Now multiply 60 over TK times DF over 60. The 60s cancel out, giving us DF over TK. Thus, we can write AB over AC is equal to DF over TK. AB is equal to C, AC is equal to B, DF is equal to sine C, and TK is equal to sine B. Therefore, B over sine B is equal to C over sine C. We have now proven in both cases that B over sine B is equal to C over sine C. By applying the same arguments to sides B and A, one gets that B over sine B is equal to A over sine A. Thus, A over sine A is equal to B over sine B, which is equal to C over sine C.